Hi, I'm Jared, back with another simple science demonstration on the whole idea that warm air rises, cold air sinks. And it's true for water, and the cool thing about this is it's kid-friendly, kid-tested, mother-approved, nobody's going to get hurt. We have hot water, cold water, and we don't want kids dipping their hands in there, coming out with third-degree burns. We want a safe way for kids to really look at what's happening, analyze it, think about it again and again and again. And that's what science is. So we have a very, very simple setup here. You can see I have a jar of water. It's hot, hence the red. I have a jar of cold water. It's cold, hence the blue. And all we're going to do is put the food coloring in. Take the lid off. You don't have to be conservative here. You just squirt it in. You want it to be a nice, dark, deep red. And watch how quickly that red actually disperses and just totally fans out in all of the water. It's not taking long. And compare that with the blue, because it's actually interesting scientifically what's happening here. Squirt some blue in past the ice. You can see the blue sort of stays together. It's not spreading out as quickly as the red. That's actually part of the process of what's happening here. The molecules here, the water molecules, are heated, so they're moving quickly. They're moving, and it's actually helping to stir up that water. You can't see it. It's sort of an invisible stir. Here, it's not moving so quickly. You can see it's not really spreading out there. So I'm going to speed it up with my straw. Stir it up there. Stir this one up here. Make sure it's good and ready. Now what I want to do is create a column of separation between the two colors to see what happens. And it's a real simple principle. And we've all done this with soda. Stick the straw in your soda, put your thumb over top and pull it out, and the soda stays in the straw. Well, that's a different scientific concept. So we're focusing here on just one simple concept. So I'm going to start with the hot water first, dip it in, put my thumb on top, and ta-da, it's staying in there. Now here's the magic. And it's not magic, it's science. I'm going to move it over, put my straw deeper into the blue, let my thumb off, put my thumb back on, and trap the water inside. It sounds so complicated, but it's not. Here we go. Deeper, off, cap, and I have a beautiful column. And the red and the blue aren't mixing. I have the hot water on the top, the cold water on the bottom, and it's not mixing. Why? Warm air rises, cold air sinks. That warm water is a whole lot lighter and less dense than the blue, and it's not separating. I can look at it. I'm a kid. I'm not getting burned. It's beautiful. Now if I leave this sit long enough, the temperatures will even out, and they'll start to mix. You can see it sort of starting to happen right in the middle. It's cool. What if we reverse it? That's where you see the science happen. So I'm going to start with the cold and then go into the hot. Have the kids think about what's going to happen. Have them predict. Have them make a hypothesis and test it. If they mess up, so what? You dump it out. It's cool. I have my blue. Now I'm going to go a little deeper. Take my thumb off. What happened? Almost instantaneously. They're mixing. You can see the red actually rising in the blue, and they're mixing. Why? Warm air rises, cold air sinks. Warm water rises, cold water sinks. Such a simple concept that kids can play with and learn about at the same time. That's science. I'm Jared. Thanks for watching.